This is the setup for the inelastic collisions activity. The purpose of the inelastic collisions activity is to show that inelastic collisions also satisfy the conservation of momentum. When we rolled the ball bearings together, those were elastic collisions in that they bounced off of each other. An inelastic collision means the objects are going to stick together. Most collisions are somewhere in between. They stick a little bit and they bounce a little bit. But in this case, it's going to be a perfectly elastic collision because we're going to have Velcro on the end of the carts. So one of the carts is going to have an extra piece on top to run through the photo gate so we can measure the velocity. That way we won't have to use the little blue dots on our video physics. The cart that you push is going to be cart 1. The cart that starts stationary is going to be cart 2. It doesn't matter if you go left or right or left. And we're going to run through all the combinations of having 0, 1, and 2 bars on both carts and see how that works. Before I go into the details of setting the lab up, I just want to show you real quick how the lab's going to work. You're going to have this cart setting here. You'll need to know exactly where that cart is position-wise. You can use the yellow tape. You'll come up, you push the car like we just saw. The first cart will go through the photo gate. They will collide and stick together. The photo gate, we're going to have to enter the data for this extra piece so it can measure the velocity. So then you will read the velocity of the first cart off the photo gate. The second cart, you're going to need the time to go with the distance. Now, if your carts go all the way and hit the end, then you push the cart too hard. The carts need to stop before they hit the end. That allows us to use the fact that VF is 0. And we can go back to our Unit 1 formulas. If the final velocity is 0, all we have to do is find the average velocity and multiply by 2. Again, you're going to need to know exactly where this one starts, and then when it ends, you should be able to measure that very accurately, the distance they go together, and then you should get a good close-up with your video physics of the time it takes from contact to when it stops. And you can push it a little harder than I pushed it, but don't push it to where, if you push it, it runs to the end, then do it again, and don't push it quite so hard. This is a close-up of the extra piece. Your piece may not look exactly like this. I'll use different pieces of metal. You need to make sure, because as different people use the labs, when you put the bars on here, this will have to get raised up. And you'll need to make sure, that, especially if you have one bar, that this extra piece is the only thing that affects my lab quest. So you can see I'm pushing it through. It becomes blocked and then unblocked only when this piece goes through. If there's some other piece, something else on the cart that blocks it, you're going to get bad data. So you want to double check that. Once you've attached the piece to it, you want to make sure that the extra piece is the only thing that affects the photo gate. When you weigh the carts, you'll need to weigh the extra piece with the cart. To use the photo gate, we'll have to set it up like we did when we ran the ball bearings through the photo gate. So you have to make sure that the timing is actually set on gate and not motion. So if it's set on motion, which if you just first turn your LabQuest on, it will be, we need to go change it to gate, and we have to enter the length of the object. So I'm just going to enter a number in to remind you how to do that. So that means part of your lab is to measure the length of that piece. You only have to do this once. And you hit done, and it'll be in there, and you hit OK, and you should be good to go. If you get that message, discard the data because you don't want it. If you did, you would, because it wouldn't be any good until you set it up this way anyway. When you run the cart through, it's only going to take one data point, so it makes it really simple. You can find the velocity. The velocity of cart 1, which we call V1, is going to just be right here. You don't have to do any averaging or analyzing because there's only one velocity because you're only breaking the photo gate once. The lab notebook is pretty simple this time. We, as always, have the title, Inelastic Collisions Activity. The table's in two parts. There's too much data, at least for me. If you can get all this all the way across your sheet, that's fine. But I did it in two parts, so I'd make sure I had room. You see you're going to have 9 trials. Cart 1 is the one with the extra piece. We're going to go 0, 0, 0, 1, 1, 1, 2, 2, 2, and then 0, 1, 2, 0, 1, 2, so on and so forth. Okay. Turns out when I actually did a real life data because I wanted to make sure my setup would work, and I did it with 2 cart bars on each cart. So my mass was 1546 for my first cart. I measured that. Notice it's a little bit more because the extra piece weighed a little extra, and that's the second one. This is the measurement I got from my photo gate. In fact, if you look earlier in the video, that's the number that was on the photo gate when I measured the velocity. So down here, I found my momentum. My initial velocity is 0 for this second cart, so that doesn't contribute. So my initial momentum is all due to my first cart and the first velocity. So I multiply these together and I got 606, and it's kilograms to meters per second is the units, and that 606 went up here. Then I took my distance data, and you notice I went to 3 decimal places because you can do that for meters because you have, it's going to be sitting there. You can just stare at it as long as you want to decide how far it went, and you know exactly when it started. So this data should be very, very good for the distance. This should be within 0.03 or better because you're not going very far, so you should be able to get a really close-up view of the time for the second, where it's actually the combination of the second cart. So I measured those numbers, I plugged them in, just found average velocity, which is x delta x over delta t. I got 0.09. And again, because my final velocity is 0, my velocity that I had right when they made contact is going to be twice my average velocity, which is 0.18, and that goes right here. Now I can combine my masses. Because I only have one velocity, that means I have basically one mass. These two masses added together, so I added those up, multiplied by my velocity, and I got 549.5, and actually turns out, and you can put it on the second page, but I went ahead and stuck it up here, that my percentage difference was under 2%. So I think this method will give us much better results than the blue dot method, and it also is a good review of our Unit 1, some of our Unit 1 material, being able to use the average velocity. So good luck.